name is CJ Reddy. I'm the Vice President of Business Development for Electromagnetics at Altair. My focus in the company is to help customers with high frequency electromagnetic solutions. So this includes, not only spectrum allocations and management type of simulations, but also the antennas and antenna placement and electromagnetic compatibility, including the multi-physics simulations of them. But I also work on advanced topics such as machine learning, 5G, ADAS, which is advanced driver assistance systems, and so on. Of course, I also get to work in the evolving technologies like 6G, autonomous vehicles, Internet of Things, and artificial intelligence. Altair was founded by our current CEO, Mr. Jim Scarpa, in 1985. It began as a very small company in Troy, Michigan, and has now grown into a multinational company with 86 offices in 25 countries, with more than 3,000 plus employees and 15,000 plus customers worldwide. We also trade publicly on NASDAQ. Of course, three main pillars we have now as a company, the vision, I guess, is simulation, high performance computing, and data analytics with AI, artificial intelligence, and machine learning. So with these three things, we would like to help our customers to design innovative products that can change the world in a way, I guess. And to that extent, we offer comprehensive engineering simulation tools that can aid in the complete product design from the, let's say, from the concept to the prototyping. All the simulations can be done, including manufacturing and those kind of things. So specifically for the spectrum side of it, we have three leading electromagnetic simulation tools. One is Altair FECO. It's, by the way, spelled as FEKO, FECO. And the other one is Altair WinProp. Third one is Altair RAV. FECO mainly, is used for antenna design, placement of antenna on platforms, co-site interference of antennas, radar cross-section or RCS, electromagnetic safety, and hazards of electromagnetic radiation to ordnance, sometimes referred to as HERO, personal, HERP, and fuel, HERF, and EMC, and those kind of things. Very, very accurate solutions for these type of simulations. Just going beyond the details of antenna design and placement of antennas, the other product we have, Altair WinProp, is an EM propagation radio network planning tool. So it uses ray tracing tools for fast and accurate propagation analysis. Of course, we can also include wireless protocols into that. And with that, we can also compute, let's say, bit error rates, data rates, and channel capacity, and those kind of things. So it is widely used in 5G, 4G, 5G, Wi-Fi analysis, Bluetooth, LoRa, wireless interference, and RF safety type of applications. The third product we have, Altair RAV, it has most, if not all, of the ITU propagation models. ITU standing for International Telecommunication Union propagation models. So it can do propagation analysis on large areas like cities, countries, and continents, even continents. You can take the whole world and do the propagation analysis with those tools. Of course, we can also do radio and radar coverage that can include JAMAS and spectrum management and allocation. So it has got the tools that can do spectrum management and allocation capabilities. So it's a very good question because there is an increase in wireless technologies, Wi-Fi, Bluetooth, 4G, 5G, smart homes, smart grid, and CV2X, cellular vehicle to X, automotive radars. There's, this is just a short list of many, many wireless things that are coming into picture. These frequencies of these applications can range from 100 kilohertz to 300 gigahertz. But that's a very broad spectrum of things that are going to happen. So one of the things, of course, in the past, what people used to do is that for propagation analysis, they used to take measurements, a huge measurement campaigns that can cost money and time. And they're not always accurate because they're limited by where you take the measurement. But nowadays, the sophisticated simulation tools are being developed with various methodologies, like the one I mentioned before, ray tracing and those kind of things that can be available for spectrum management and avoiding interferences. Of course, recently we heard this news about 5G near airports, that we cannot launch 5G near airports because they can interfere with the altimeters of the aircrafts. That's because the frequencies that 5G uses, some of the frequencies 5G uses, are in the same band as the altimeters that aircrafts use, and they could cause accidents because altimeters can get confused and then they can land somewhere else or can give you wrong information. So all these things require, it's very difficult to do take care of these things through measurements. So they require simulations. So the biggest advances are being made now on the simulation technology from antenna to system level simulation. By that, what we mean that you have to use antennas in their in situ situations, like where they are mounted, to be able to take them into account in the system level simulation. So that's where we come into the picture in terms of simulation tool vendor, you can put it that way. For antenna simulations, for example, FICO, our product offers multiple solutions that range from what we call full wave solutions. That means they solve the governing equations, Maxwell's equations, very accurately and can give you accurate answers if your CAD model and meshes, right kind of thing. But we can also do antenna placement. That's very critical because antennas can work very well on their own. But once you place them in some place on a platform like aircraft, ship, or spacecraft, or whatever it is, their characteristics change, their radiation pattern will change. And it's very critical that those patterns are taken into account in the analysis of the propagation to be able to more accurate and more close to reality type of analysis. So that brings us to the propagation analysis that we have with the WinProp and RAP. Not only with empirical formulas, for example, we mentioned the ITU models, but also ray tracing tools that avoid expensive measurements. And MIMO, because multiple input, multiple output is also becoming popular. It's already become popular with 4G, but it's going to become even popular with the 5G, what they call massive MIMO, that includes beamforming and statistical analysis. All these things require very sophisticated tools, and we are actually on the forefront of developing those kind of tools and providing to our customers. Beyond all these things, one also has to be able to include the air interfaces, like protocols of your Wi-Fi communications that can be used for bit rate calculations, channel capacity, 5G NR, the new radio protocols, including numerology of the subbands and those kind of things. So you require all the way from antenna design to the radio specifications wise to be able to understand what spectrum is doing and how the spectrum interacts, different frequencies interact for different protocols and those kind of things. And our tools, I guess, are able to provide that kind of simulation capability. So coming back to the increase in the wireless technologies, right? We already said there's Wi-Fi, Bluetooth, 5G, 4G, smart homes, and smart grid frequencies going all the way from 100 kilohertz to 300 gigahertz. So these things, not in the analysis part, because it requires analyzing large city blocks, for example, large rural areas, large suburban areas, or the terrain that has vegetation and those kind of things. In the ray tracing analysis, one has to take into account, let's say, direct interactions, single and double reflections, the diffusion, scattering from rough surfaces, because as frequencies go up, the surfaces which look smooth at lower frequencies will look very rough at higher frequencies because the roughness becomes comparable to the wavelength. And material properties, they become important as well at higher frequencies. All these things need to be taken into account while doing a very accurate propagation analysis. Spectrum sharing becomes complicated without knowing the propagation phenomena at wide range of frequencies. Because they're covering from 100 kilohertz to 300 gigahertz. In addition, one has also to think about intermodulation products, harmonic interferences. Intermodulation product means if two transmitters at two different frequencies, they can combine to create a new frequency for interference. So those things need to be accounted for, and harmonic interferences. The transmitter may be transmitting at one frequency, but it may have harmonics that could interfere with other things. So all these things need to be taken into account. And we are, I guess, enhancing our tools at Altair to be able to include all these effects without consuming enormous computer resources. That's also key there. If a computer takes 10 days to compute or 15 days to compute, that's not going to be useful. We have to do it very fast. And that's where our high performance computing tools are also useful for this challenge. Because Altair develops these simulation tools, where they're all cutting edge high frequency tools, allowing companies to optimize wireless connectivity. From antenna simulation to antenna placement, radio coverage, network planning, spectrum management to electromagnetic compatibility and interference, radar modeling, bioelectromagnetics, and RF devices. So FICO combines with other tools to optimize system performance even through machine learning and artificial intelligence, and reduce modeling time for complex systems. So our goal is to partner with other companies to offer simulation services and development of new propagation and network planning tools that are needed for the evolving spectrum management needs. This way, we are not the ones who are going to do it on the field, but we are the ones helping the companies to do it on the field by using our simulation tools, so they can enhance or make it less cost and less time consuming for them. So already we talked about the spectrum management, but also there are many other EMC issues, electromagnetic compatibility issues, that also will require attention in the spectrum management. One is the co-site interference among various sensors and wireless devices, and also signal and power integrity issues of PCB circuits. When you have a lot of PCBs around, they can interfere with each other, but also their signal integrity and power integrity, and radiated emissions from PCBs, and also their enclosures. So designing proper enclosures that prevent radiations from these PCBs can also be very, very important. Radiated susceptibility and emissions from cables, because cables also need to be shielded enough that they don't radiate. And also they're not susceptible to outside radiation that are connecting various electronic devices. Radiated emissions and their effect on antennas and vice versa. So antennas can radiate and interfere with PCBs, cables, and of course cable radiations and PCB radiations could affect antenna performance. So we have a comprehensive tool set for simulation of various aspects of spectrum sharing and spectrum management. So of course, our tools are not just available for defense applications, but also for commercial applications as well. So we work with any of the industry sectors that have these kind of problems for spectrum management, and also the electromagnetic interference and the design issues and those kind of things. So when it comes to the defense, there is adversary competition. Like everybody is trying to use different frequencies, and they're trying to jam the other side's communications and those kind of things. On top of it, the commercial congestion, with all the things we talked about. So many applications are coming to picture, and that also causes the spectrum congestion that drives the need to develop new capabilities, new techniques, and better integration within the DoD and its partners. So, because at the end, we have to enhance the spectrum efficiency, maximize the spectrum compatibility, and ensure electromagnetic spectrum superiority. That's the end goal, I guess. We want to have electromagnetic spectrum superiority over anybody else in the world, for example. So we are looking forward to, Altair is looking forward to teaming up with the members of NSC to create innovative and comprehensive spectrum planning tools that can help efforts of DoD in the spectrum dominance.